Welcome back to our video module on mechanics and materials. In our previous video, we looked at a finger poke or the effects of a shot on your arm. And when somebody poked, your shoulder would kind of like deform a little bit, and with the shot, you'd have a deformation just a little bit right at the skin, and we use that to figure out that stress was force divided by area. In each of these cases, the stress applied did something. It moved the shoulder in a big area, moved the shoulder in a small area. And in fact, when we took a look at our bar that had some sort of applied force that went in this direction, and if we wanted to be proper about it, we'd have another reaction force here. We saw that it stretched, and that's where we, kind of tried to figure out what was happening at each one of those particles. So from this perspective, you can see that we have some sort of deformation. It's like a spring. We'll call this deformation delta, just because that's the convention. And the original length we'll call L. So the bar was at length L. We apply the force, and it stretches. Now the way we looked at it before is we imagine some small particle. We're going to do that here. We're going to have some sort of small particle, and there will be some sort of, a small component of that applied force. We'll call it force applied small, and in an equal and opposite direction, the force reaction small. And when this is applied, we'll also have some sort of deformation. Now, of course, this deformation will be smaller than the deformation over here because we're in a much smaller particle. But what we can kind of intuitively see is that there's going to be some relationship between the proportion of the deformation to the total length. If this one bar stretches a lot, it's because there's a whole bunch of small particles that stretch a lot. This relationship between the total length and the deformation that is experienced is the strain. Usually we use epsilon. It is delta over L. So one can easily imagine here, we double the length of the bar, and now we have this delta plus this delta. So we have twice as much delta. In that case, our strain is going to remain the constant. And the same when we take a look at a really small particle. We're basically just cutting this length into really small sections, and we'll see a really small delta. So in summary, what the particle feels is stress, the force per unit area. How the particle reacts to that is the strain, or its springiness, its distance per unit length. Stay tuned in our next video when we jump into this with a little more depth.